Okay, so tonight we are going to talk about the quantum nature of reality. Um, so the idea is to connect two different descriptions of our reality. The first one is a granular description. So in the first part, we're gonna start with the granular description of the quantum world, and also compare it to the continuous description of general relativity and try to understand both descriptions. Then we're gonna dig into the scaling invariance in physics, how this description shape our physical law and how the same pattern replicates across scale in the universe. And finally, we're gonna see how we can reconcile both descriptions by bridging quantum mechanics and general relativity. And then we're going to have the 30 minutes presentation and, questions and answer session. Okay, so let's start. So to have an idea of what is a continuous description of our reality, I wanted to take the ocean example, where we have a flat surface, very smooth, very flat, function of the weather. There could be waves, but we have a continuum of water, from our perspective. And if we zoom in at the surface of the ocean, we can start to see small wave if there is no wind and no current, big wave if there's a bad weather. And if we continue to zoom in at the molecular level, we can start to see water molecule, H2O. So one oxygen, two hydrogen bounding together in the single molecule, and which means when we talk about granular description, it means that we have entities, individual entities interacting together to create at larger scale, at the ocean surface scale, a very smooth and continuous surface. And even the bond between the hydrogen and the oxygen is generally pictured as a small rod, but actually it's not matter, it's more physical interaction, electrostatic interaction. And we can compare this description of the ocean with quantum mechanics and general relativity. As Olivier presented you last month, quantum mechanics is described by the Schrödinger equation. And when we solve this equation for an harmonic oscillator, we find discrete level of energy. And those discrete level of energy can be compared to the discrete packet, wave packet that have been discovered by Einstein and Max Planck about the quantum nature of light. On the other side, we have Einstein field equation describing how space-time is curved and how an energy density or a pressure can create a curvature in space-time that we interpret as gravity. Because of the curvature, if we put an object with a small curvature, it will go down the slope produced by the curvature. So we got this little drawing in the middle where we have a sphere creating the space-time curvature, and with the lines we can understand how would move an object that is put in the neighboring of this spherical object. So as I said, the quantum nature of light has been discovered by Max Planck and Albert Einstein. At the time, Max Planck was working on the black body radiation problem, because the classical description of our reality as a continuous matter and continuous atom couldn't explain the observation of the emission spectrum from a black body that was held at a certain temperature T. So when I have an object and I hit it at the temperature T, it will emit wavelengths, I mean light that has a specific wavelength, and the power function of each wavelength will have a bell-shaped curve like that. And the classical theorists couldn't explain it because they obtained a diverging curve like the red one here on the right towards the UV wavelengths. On the other side, we have the photoelectric effect that was studied by Albert Einstein. And in his experiment, he tried to calculate, okay, what is the energy, what is the amount of light I have to send on an atom such that I can extract electrons from the atom? And what he realized was that it's not the amount of photon he was sending to the atom that allowed him to extract electrons, but rather the frequency at which the light was excited, the photon was exciting and sent to the atoms. And both experimental theoretical investigation made them to make this assumption that light is not like a continuum of infinite amount of frequencies, but they have very specific frequencies, and each frequency is associated to a wave packet that we call a photon. And the way Max Planck formalized it is that the energy of these wave packets is proportional to the frequency, and the proportional constant has been named after him. So it's now called the Planck constant. And this assumption allowed him to solve the black body problem and the UV catastrophe with his Planck's law in 1901. And by solving this problem, he also discovered a very interesting point, which is that even at zero temperature, when nothing is allowed to move, where we suppose that there is nothing at 0 Kelvin, there is a background energy that we now call the 0-point energy because of the zero temperature of this energy. And what is very impressive is that if we consider all the 0-point energy of all the frequencies, we have an infinite amount of energy. So at that time, it was a little bit disturbing for them to handle with this energy, but today we're going to understand why is it fundamental for our current understanding of our reality. And the second observation is that generally the photon could be described by an oscillator, and each oscillator is described by this frequency. And generally in quantum mechanics, we describe an harmonic oscillator as a spring that is oscillating like that. But if we observe our world, our physical reality, if we observe the Earth, the solar system, the galaxies, everything is spinning, everything is rotating, self-rotating. So we believe that an oscillator is best described by a 3D sphere rotating rather than a spring, because we don't observe like natural spring in everyday life. And this oscillation will be very fundamental for later in this talk. So keep this in mind. So Max Planck discovered the 0-point energy, and then later development in quantum mechanics came with this idea of creation and annihilation operators, where out of the vacuum we could create entities that are electromagnetic entities, such that the quantum vacuum fluctuation are considered as an electromagnetic field that comes out of the vacuum. And if we want to understand how this the vacuum fluctuation, which is a discrete description of a reality, can combine with general relativity and the continuous description of the physical world, we have to go back to Einstein's field equation, and so it's very complex equations. It's a set of 16 equations, and the left part is the geometrical part, where it tells us what is the radius of curvature that is produced by a certain amount of pressure or energy density. We prefer at ISF to put it in its non-dimensional form, where we write a rho vac, which is the quantum vacuum fluctuation energy density, and the Planck length on the geometrical part. It means that if I have a pressure or an energy density for 10 U that is on the order of the 0-point energy rho vac, I will have a radius of curvature on the order of the Planck length. And a way of understanding this equation is that if I have an energy density which is much lower than the 0-point energy, I don't have enough energy to curve spacetime and create a spacetime bubble. So the spacetime elasticity, like a soap bubble, if I blow a very like weak field, weak wind, if I blow my soap bubble, I will blow, and then the surface tension will bring the soap bubble back to a flat surface. But if I blow with enough pressure, I can start to nucleate space-time bubble with a radius on the order of the Planck length. And eventually it will nucleate and create an elementary space-time bubble. And by looking at the fundamental nature of Einstein's field equation, we can understand that the first space-time bubble that appears is a bubble that is on the order of the Planck length. And this is a way to describe this background energy. In our paper, The Origin of Mass, we describe it as a Planck plasma, meaning that all those space-time bubbles appearing from the vacuum. So here on the top left, top right of the screen, we can see bubble appearing and disappearing, because we have to imagine continuous creation and annihilation, continuous appearance and disappearance of the space-time bubble. It's highly chaotic. This is why we don't observe like matters appearing out of everywhere all the time. It occurs at very small scale, at the Planck scale, and it's not coherent. And we see later how we can bring coherency in these vacuum fluctuations. And those elementary bubbles, we call them Planck spherical units, and it has the size of the Planck, and it has the mass of the Planck mass, and this allowed us to describe this Planck plasma as the water of the ocean, and the PSU are the water molecules, such that we have either a continuous description of the Planck plasma, like a fluid, in which we can define pressure, we can define temperature, and we have also the discrete description of this Planck plasma as the small PSU that can eventually aggregate and interact together if they have coherent enough. And this led to the holographic mass solution, where if I have enough PSU aggregating together, eventually forming the proton, I can describe both the proton as a continuous medium, which creates matter as in a spherical shape, or I can describe the discrete amount of PSU. And this led Nassim Haramein to his holographic mass solution paper in 2012. And with this discrete description of reality, he was able to find the black hole structure within the proton, and also to predict the radius of the proton from the mass of the proton. And at the time, it wasn't, there were two different values that were in competition, and with holographic mass solution, it was able to determine the right value that was then later in 2018 accepted as the real value for the radius of the proton. And later, with the origin of mass paper, we refined this discrete description of space-time, especially by describing the proton mass as a double screening mechanism, with the mesh of the screening that's increased between the black hole structure as single PSU to the rest mass structure with aggregate of PSU. And the reason why I show you this is to start to give you an idea of how those elementary Planck spherical units are the building blocks of our reality. So if I start with one PSU that aggregates in what we call kernel 64 PSU aggregating together. And when I talk about aggregation, you have to keep in mind that those are small oscillators that rotate. And it's the coupling between the two oscillator, the two oscillation, that allows them to bind together and to create a first structure. Then those structures aggregate and then create larger structures such as the proton. And then the proton aggregate together and create molecules. Then the molecules aggregate together to create proteins. And the proteins eventually, here I put the example of the collagen. Collagen is three chain of proteins, and then those three chain of proteins, if I take those three chains, I put them together, I can create a tropocollagen molecules that then aggregate in collagen fibrils and then in fibers and et cetera, and can eventually create bones, tendons, and also our skin. So with this example, I try to give you the feeling that the organization that we see at the cellular and tissular level, at our physical body level, is mediated at the origin by the quantum nature of the reality. It means that those elementary interactions dictate how the interaction between the molecule behaves, and how the molecules together can create cells, and then how they can create organs and human bodies. So this self-assembly mechanism led us to consider the physical world as a fractal construction of the Planck scale spherical unit. And if we look at a fractal, here I put an example of the Julia set. So a fractal are constructed with one very simple rule. So in our case is how two PSU interact together, two spherical units interact together, can create much larger scale patterns. And we can see that in this example, we have two characteristics. We can see that there is branching phenomenon, and we can see also spiral behavior. And of course, it depends on the elementary rules at the beginning, but in our case, the fact that we have rotating oscillator, we have also this spiral. And if we look at different phenomenon that looks like fractals in nature, we can see that we very much observe the branching property, for example, in snowflakes, in electrical arc, and also the spiral property. Here I put an example of aloe vera leaves, and also the black hole at the center of the galaxy. And we can have also much more examples of spiral behavior and branching behavior. And those spirals that are related to the elementary oscillation, rotation of the oscillator, is really important because it will tell us how the different scales communicate, how from very large scale and very small scale are connected. And this helps us to describe what we call the scaling law. Olivier showed you this graph last month. And I just put it here to just remind you that by understanding the very small scale, by understanding the proton structure, we can understand how those rules can goes to larger scale and eventually to the cosmological scale. And now that we have seen the fractal nature of reality, the gradient of the description from the quantum vacuum fluctuations, we will be able to we are able to connect the two, the space-time curvature and the vacuum fluctuations. Okay, I promise it's the last equations of the presentations that certain people are not very familiar with it. Don't be afraid. So the vacuum fluctuation, which is the granular aspect of reality, are best described by the correlation function, which means how two elementary particles, two elementary oscillators interact together. Are they coherent or are they not coherent? Earlier in the presentation, when I introduced the vacuum fluctuation, I told you it's completely chaotic, meaning that if one PSU appears here, it doesn't mean that very close to it, that we'll have another PSU appearing from the vacuum. But if I am able to create enough coherence in the region of space, I will start to have like PSU well aligned and rotating together. And this is best described by the correlation time, which is defined as the scale, so the radius r, the shape, the scale of the object I try to describe, and the velocity of light c. On the other side, we already described the space-time curvature and how the space-time curvature is defined by the energy density of the object I'm observing. And to understand how I can create coherence in the Planck plasma flow, in this background energy, in this background spherical unit appearing from the vacuum, we have to look at the cosmological mechanics. So the universe is rotating every day, every second, I mean, every instant. Recent approximations say that apparently it requires 500 billion years to do 1 ton of the universe, the current estimate of the size of the universe. And if we picture our universe as the gears in the clock that interacts together, we can understand how the massive angular momentum of the universe is then transferred across scale to the proton scale. So here I put, for example, a galaxy, the Milky Way, that is rotating, and its angular momentum then transferred to all the solar system, all the stars and planets around within it, that then transfer to the planets, then to the atoms, and as we saw earlier, also to the quantum structure with the Planck plasma flow. So I describe it from the universe to the Planck scale, but there is no reason why it shouldn't be the other way around. So maybe it's the Planck scale rotating that create larger structure and then create the universe. And at the Planck scale, this angular momentum creates coherency. It creates a flow. So there is a preferential direction of the spin of the Planck spherical unit. And this coherency creates an energy density, creates a certain amount of electromagnetic energy density. And this energy density, if it's strong enough, as we saw earlier, can curve space-time and create a first elementary bubble. And at larger scale, when we observe larger decoherence time, we can observe the formation of protons and then atoms, and then even larger scale like stars and then galaxies and cluster of galaxies. So by describing the source of this stress energy tensor as the decoherence mechanism of the vacuum fluctuation, we can connect a discrete description of a reality to a continuous description of a reality. And this was the major discovery in the holographic mass solution, was to have both description. How with a discrete description of a reality, we could find the black hole structure of the proton and then the rest mass, and understand why the mass of the proton was, the observed mass of the proton was so small. And another question is that we saw the origin of the mass paper was, why do we need a continuous description of space-time? How is it relevant for us? And the answer comes when we look at the nuclear structure. So an atom is an aggregate of different protons. So if we look at two neighboring protons, and we can calculate the curvature that induce both protons, we can calculate the gravitational force that they apply to each other. So this gravitational force, due to the curvature of space-time, if they are close enough, they attract each other. And there is another force, which is the electrostatic repulsion force. And if we put them at a distance where the electrostatic match the gravitational force, I mean, I put arrows on the F, but it's more the modulus, we can have an equilibrium, a balance between the electrostatic repulsion and the gravitational attraction. And this was the definition, the early definition, the first definition of the residual strong force, of the nuclear force. So the strong force was conceptualized because physicists at the time couldn't understand why protons that are supposed to repulse each other due to the electrostatic repulsion force could stick together and form the nucleus of an atom. We have another force, which is the same force, called also the strong force, but it's more the confinement force of the quarks within the proton. So in the standard model, the proton is made of quarks. In the holographic mass solution, we challenge this description of our reality, but by understanding how the proton mass emerged from the curvature of space-time by the quantum vacuum fluctuation, we were able to calculate the curvature of space-time and find exactly the same value as the strong force measured in lattice QCD. And this was the last figure of the origin of mass paper. So by combining this granular description of the physical world to this continuous, we were able to reconcile the real nature of the strong force, which is a gravitational force. And such that we could understand how the strong force emerged from a gravitational interaction between protons, and this gravitational interaction emerged from the electromagnetic nature of the vacuum fluctuations. So this is why it was really important, and we have made a major update of this paper, The Origin of Mass, and it's now we are now able to calculate from a general relativity from the Einstein field equations the proper curvature of space-time, and we have recovered all the data in the literature concerning the strong force. So this is why it was so important for us to reconcile both description from quantum mechanics and general relativity. So I'm reaching the end of the presentation, so thank you for your attention. And now we're gonna move to the question and answer session. Okay, so if I take the different questions, so I will ask maybe the first one, François. No, François to join us and ask his questions. Can I invite you? Or... Maybe not. Okay. Hello. Sorry for this. I try to invite François online. Okay. Oh, maybe I cannot. François is asking. Basically, my point of view is that the most fundamental possible reflection on the origin of everything must begin with a discrete approach. This is induced by the idea that consciousness is the most fundamental aspect of existence, and that it can be defined as the process of or state of relationship between a subject and an object. Oh, yeah. François, do you see my my invite to join the live? No. Okay. Sorry, François. I don't clearly understand your question. So I've got a question from Liv. How does this change perception at biological level? I'm not sure about what you mean by perception, but what I understand is if we want to describe the way we perceive reality, if we describe the most of the time, okay, we place the consciousness and the perception in the brain, and if we want to really understand how the brain works, how the neuron works together, we have to describe the neurons as cellular entities, but those neurons are made of proteins and that are made of atoms that are made of protons. So if we want to understand all the relationship between what we perceive and the nature of reality, we need to understand how the protons are constructed from the vacuum. And once we understand all those relationships from the cellular level to the Planck scale, we can have a better description of how a cell works, how the neuron works, and how we will perceive our environment. So and anyway, so the question once, so someone reacted, unfortunately, this does not solve the final question, what holds the Planck and the sub-Plancks? So on this question, so what happens at the sub-Planck? So why do we stop at the Planck scale? It doesn't mean that there is no scale underneath. I mean, it's sub-Planckian scale. It just means that the way we perceive a reality is related to a certain scale, by the way, a scale allows us to make measurements. So if I want to have my height, I use meters or inches. And for example, I'm 2 meters high. If I change the scale, I will have a larger height. And this change in scale changed the measurement. And the law of physics that we describe is that we have discovered across years throughout the humanity are established to describe the world we perceive at our scale. By studying our scale, we can understand the relationship between the different scale. This is why I showed you the scaling law. And once we understand the difference between the Planck scale, the atomic scale, the planetary scale, the star scale, and then galaxies, clusters, and the cosmology, we can find patterns to go from Planck to the cosmos, but we can also use the same pattern to go down to lower dimensions. And there is no reason why we should stop at the Planck scale. Due to the fractal nature of our world, I mean, the same scale goes down, down, and down. The question is how everything started. I mean, what is the cosmogenesis? Why at some point we had a universe and maybe one Planck or one small element get out and then expand, and by expanding create a depression, and the depression create vortices to compensate the loss of pressure. And those vortices are the angular momentum required to create the coherency in the Planck plasma. And each vortices create, for example, an atom. So this is one way of describing how everything started and how we can go lower to the Planck scale, and probably the same way we have self-assembly mechanism, we can go at the sub-Planckian scale to have other type of processes that occur. For example, I'm thinking about information transfer, how we can communicate at much higher speed than the speed of light using like sub-Planckian network. And we should be able to use the same mechanism that we describe at the Planck scale for lower scale and larger scale. Okay, I hope I understand. I would have loved to invite people. I'm sure it's possible, but I don't know why. Why? Well, I will continue the questions. I've got a question from Justin. How do you envision the interaction between this structural vacuum and consciousness, and how do you see potential experimental pathway to detect or quantify that interaction? So the consciousness problem was addressed in one of the paper from Nassim and William in 2016, where they described the space memory network and how our experience, our everyday experience, is stored in the Planck plasma, as if we had a gravitational memory. So in the presentation, I showed you the solar system as advancing in the universe with the stars rotating around the sun. And once we advance, we follow a universe line. In general relativity, is called a universe line. And the fact that we have this trajectory, we have an imprint in the vacuum. And this imprint is like a memory that then inform the whole structure. And I also use, so this is the first element of the answer. The second element is I showed you, the gears of a clock, meaning that all the pace you at the Planck level can interact together and transfer information. And the black hole structure of the proton allowed us to understand that within the proton, we have the energy of the entire universe. So the vacuum that is stored in the proton is the whole energy that is commonly observed in the universe as the baryonic matter, the dark matter, and the dark energy. And this made us to understand that all the protons are related together in a huge network, such that all the experience I have now, all my protons send information to the whole network. So the gravitational imprint goes into the network, inform the whole network, and I have a feedback mechanism. So yeah, once my experience have informed the network, I'm part of the network, so I'm entangled with it. I cannot just disentangle me. I'm entangled with the table, with the chair I'm sitting on. I'm entangled with everyone around me. And once I've experienced something, I inform the network, and the network inform me. So the way they start to describe consciousness is how this feedback mechanism give a self-perception. So I'm experiencing something. I inform the network has moved, and I can feel the feedback, but everything happens in a very short amount of time. It's very rapid, so that I cannot see like a lag between my experience and the feedback of my experience. This is the way I picture it. I know we are still developing those description. Nassim will give a presentation at a conference in Barcelona next July about the physics of the consciousness. So stay tuned. I think we're gonna publish a new material on it, and it's a very, very interesting question, and I'm really glad that physicists start to address these questions. I'm thinking about George Penrose or Bernard Carr. Bernard Carr, by the way, that was one of the first physicists to establish a scaling law between the different scale, between the proton scale and the cosmological scale. So here are a few elements of answers. I'm gonna take another question. Why are there not neutrons, or with other words, why are they necessary? Why do they have to be neutral in order to allow the existence of elements? The question is, okay, why do we have protons? Why do we have neutrons? And why in larger element than the hydrogen, we require to have neutrons? This is related to the question of the charge, how the charge emerge from the proton. We have first element of answers, but we are still developing this part of the holographic mass model about the charge, how the charge emerge from the Planck plasma. The feeling that we have at the moment, the intuition that we have is when we describe the velocity field within the Planck plasma. So we've talked about how the proton is a rotating spherical rotating oscillator, and a better description, I showed you a short drawing of the proton as two torus together, meaning that the toroidal shape is like a 3D vortex with a toroidal circulation at the equatorial plane and a poloidal circulation that go around the donuts here, that goes to the center of the proton donut. And those two circulations are related to how two protons will interact together. And when we solve the fluidic equation of those circulation within the Planck plasma, we can see that there is a conservation of angular momentum that create a counterflow around the proton. So maybe a way to describe the emergence of charge is more the direction of the rotation and the counterflow around it would create the opposite charge. I've got a flow like this, and around it at much larger distance, the Bohr radius is 10,000 larger than the radius of the proton. So if the proton is rotating this direction, the flow around it will be in the counterclockwise direction. And these are the first elements to understand how the charge emerged from the Planck plasma. But it's still in construction, so I don't want to give you more details. It's more like heuristic element to understand how the charge will emerge. And when we have this picture of, okay, direction of rotation, if I assemble different protons together to create the nucleus, the overall angular momentum maybe is not the sum of all the angular momentum, meaning that the charge of the whole cluster is not the sum of all the protons, such that what I perceive as a charge is only a certain amount of the proton that have been put together, meaning that if I come across a neutron in life, it's not very common if you're not a particle physicist, but my intuition is that the neutron is not made to last in time. If I let a neutron alone in the universe, it will decay very rapidly into a proton, because it cannot stay without this counterflow and without creating the small vortices that create the charge in the Planck plasma. So it's an attempt of answering these questions. I hope Leonardo is happy with that. People say that my audio is distorted. Sorry for the distortion. I hope it's solved now. The fact that I'm alone for the live, I couldn't present and look at your comment at the same time. So there is a question of Mike. If protons, stars, and galaxies are black holes, what about intermediate size? I describe you the scaling law from the black hole structure of atoms, of stars, of galaxies, how there is a black hole in the middle of each galaxy. So it enables us to change in scale. But for example, if we place ourselves at the star level, at the star scales. So for example, the sun, it will create the scale of the solar system. But then in this scale, we can calculate some frequencies that are around these scales, but it's not just one frequency, as in resonance pattern, when we have one big how do you say that? One big element in the middle, and we have like secondary frequencies. And the planets and the orbits of the planets will be those frequencies. So once we have the vertical law, scaling law between protons, stars, cluster, etc. We can then investigate how the frequencies are in resonance and how they create, like when we throw stones in the water and we have like one big hole in the middle, and then we have those ripples on the water surface. And so one scale is the first hole, and then the ripples will tell us, for example, how at the proton level we can then create higher complexity of organizations, and that will then create human bodies. For the stars, is more like a planetary level. So it's as if we had like vertical scaling law with the black hole, and then we have horizontal description of the scaling law, that will create the different planets and tells us where the planets are supposed to be, what are the size that they are supposed to have, etc., etc. And in the construction of the theoretical model we are developing with the holographic mass solution, the next paper will be on the Planck plasma flow, on the thermodynamic of the Planck plasma flow. And if we succeed, we're going to have also a description of the charge, how the charge emerge from this Planck plasma flow. And after that, the third major paper will be about descaling law, both the vertical and the horizontal one. Thank you, Mike, for your question. Oh, wow, I see that you wrote a lot of questions and articles with the proton and neutron as quantum of mass, which are added injected by defect. How does this mean? Okay. A question from Gisela. Is the universe a torus inside a black hole? Has it been agreed by physicists that space is a black hole with toruses, with black holes in their centers that connect them with space? Do photon and electron carry, like protons, the information of the universe? So yes, so early calculation from Nassim demonstrated that the universe is clearly a black hole, and that we live in a black hole. And a good way of picturing yourself in the interior of a black hole, it's defined by the Schwarzschild radius, the Schwarzschild condition, which is the first solution of Einstein field equation, and that relates the mass of the black hole and the curvature of the space-time that this mass induces on the space-time metric, and its size, its radius. And if we, for example, if we have the density of the atmosphere, the air, we live in our atmosphere like every day. And if our atmosphere was big enough to go from the sun to Mars orbit, we would create a black hole. So it means that a very large entity with a very small density like the atmosphere, the air atmosphere, can create a black hole. So in the case of the universe, it's so huge. I mean, the radius is so large that the density is extremely small. For us, it's like vacuum. And now there are like recent publication from other scientists, from astrophysicists that are doing experimental measurements that start to come to the conclusion that we are living in a black hole. I mean that the universe meets this black hole condition that was already predicted by Nassim and his calculation. And the torus shape is just a way of explaining how we can have angular momentum in 3 dimensions. So in 2 dimensions, when we have the surface of water in the bathtub, and then we unplug the bottom of it. I don't know the name in English. Then we can start to see the water like flowing down and create a vortex. We could say that it's a two-dimensional vortex. But when we are in 3D, there is nothing that flows from above to the bottom. So a way of picturing it is that if I have a tornado and then I close the tornado, I put the top of the tornado with the bottom, I can create a self-consistent vortex in 3D. And this creates a torus, such that I have the toroidal circulation and the poloidal, such that if I describe the trajectory of a particle at the surface of this torus, it will go down, then up, then go in the middle, and then go up, and then do something like this, you know. You have to picture maybe how do you call that? Yeah, like a spiral that goes round. And there are some observation, especially at the cosmological level, when we look at the Milky Way with the arms. If we look at the trajectory of the stars in the Milky Way, they follow these patterns of, so they rotate around the center, but they also have this poloidal circulation, which clearly indicates that there is a torus. I mean, the structure of the torus is the main structure. And also another good hint about why we have this toroidal shape everywhere in the galaxy. I mean, in the universe, in each galaxy, because some of the galaxies have what we call jet. So sometimes maybe you have seen this picture of a galaxy that have a very long jets above and underneath. And those jets can be extremely long, like 200 million years sometimes. It's extremely large. And this is due to the fact that when the matter goes in the center, if it concentrates enough, they can have like a massive repulsion in the center of the torus, here in the very center. And the only way for the matter to be extracted extremely rapidly is to create those jets in the center. So those are like few elements indicating why the torus shape seems to be the right one. And a last maybe explanation for the toroidal shape is that the easiest way for an electromagnetic wave, because one of your questions, Gisela, was about the photon and the information in the universe. The easiest way for an electromagnetic field to flow, I mean, to flow across the universe without spending much energy, is to follow a toroidal shape. Because from a pure theoretical point of view, it's related to what we call Beltrami flow. Beltrami was an Italian scientist. I don't remember, maybe it was 18th century or 19th century. That was, he was studying, okay, if I have an electromagnetic field, what is the shape of this field such that it doesn't feel the Lorentz force? Meaning that if I have a charge in an electromagnetic field, what is the least energy pathway? And interestingly, he found a structure of the trajectories that follows torus, and which means that maybe the way our reality structures, the way this connection between electromagnetism and gravity is structured, is in the most efficient way, and this most efficient way is the toroidal shape. The fact that we have a relationship between the toroidal circulation and the poloidal circulation. Wow, you're asking good questions. Good question. I see that there are still a lot of questions. Fortunately, I cannot take them all. We're gonna publish this recording on YouTube, so please feel free. We're gonna save also the questions. Feel free to ask the question that I couldn't answer on the YouTube video, and we will provide more answers directly on YouTube. And I think that's it for today. Thank you everyone for being here today. I was really glad to present part of our work, and we are still like putting a lot of effort in improving the description of the holographic mass model of these solutions, and so that we can transfer it to the technologies the guys in the lab are developing. I'm working more on the theoretical parts, and now we are building the team that's with a lot of electrical engineers and scientists from all around the world who wants to help. And it's really incredible to be part of this experience and to yeah, to work with all the ISF team. And I hope you enjoyed this Think Beyond session, and I hope to see you to the next one in a couple of months. And I wish you all a lovely evening, and see you soon. Bye, everyone. Thank you all for your message also. That's very kind. Bye. Thank you.